Hello and welcome to this third part of my generics video. Now, I have made more than 3 videos about generics, but this is just like the third let's just talk about generics videos that I've making, all right? And let's just jump straight in. So if you haven't watched the other videos, don't worry about it. You're pretty much going to learn generics in this anyway, but it's just another video to go a little bit more deeper into this because it's important that you understand generics, and sometimes you need to be able to look at it from different angles. So what we have here is we have this tester protocol with associated type T and a return function of get item, and that's going to return the actual T item with inside of it. All right. So what we want to do is we want to be able to create multiple concrete types, but then also be able to have functions that return a tester protocol that has an associated type. And but we don't want to be using opaque types or any box protocol types. Opaque protocol types, box protocol types. We just want to be using old school generics, all right? And so let's start by creating a struct that conforms to tester protocol, first of all. And as we can see, we need a function that says get item, and that's going to return an item. Obviously, we now need to say that the item is then going to be of type T, okay? And when we then try and compile this, we get some errors. All right, so let's just fix the errors first so we can make this one compile. Well, the compiler doesn't know what this T, the type of T is. When I say type of T, is it an int? Is it a string? Is it a collection? Is it whatever, right? Is it another struct? What type is it? So we've got to tell it what type it is. Now we have a couple of ways of doing this. We can say type alias T is equal to int, for example, and then it's all happy. But we're not generic anymore, right? Well, this tester is specific to an int. We want to make it generic to tester protocol. So this associated type can take on any type whatsoever. So type alias in this situation isn't the right one for us. So we've got to start going to extract it through the parameters up here. And here we can then start saying tester T. So now it's more the declaration where we're going to define what tester this is, right? And now, because it's a struct, we get initializer already for free, and we can say tester item 1. And we use type inference. We can see tester is of a generic type int, all right? Because we've basically told it here through type inference that we knew that we had an integer as its argument, and this item has of type T. So the compiler said, okay, well, item is now taking on integer. Well, we know now that the return type of item, this matches. So T and T, this matches. So we now know the T is integer. And this was the compiler did this in the background. And it just inferred what was its argument here. It tried to build everything as much as possible and say, I'm just going to keep building it until I see something that I can't do. So it said, okay, I've got a tester, and I've got the parameter. The first parameter is then item, and I've got a value for that. What type does that have? Integer. Okay, let's have a look. Can I match it to this one here? Let item T. There's no other constraints or anything like that. Yes, let's just change T to integer. So it changed T to integer, and it went, okay, function, get item T. Well, wait a minute, I've just solved what T is. Let's change that to integer. So now we're seeing, look, get item returns the correct type, and we know what T is now, so we don't have to worry about this. And we can even remove the generics from this because we've told the compiler what specific type we're using. But once again, we don't want specifics, we want generics, okay? So we've now got this T, which is really good. So what about having now a function that says get tester instead? And then we're going to return a tester protocol, and we're going to then say, then a value of int, all right? This is where it gets a little bit more interesting. So we're now going to say get tester item value, and we'll try and compile this. So use of protocol, tester protocol as type must be written as any tester protocol. Remember, we don't want to use any or some. We're using legacy style generics where we don't have access to this, okay? And we want to be explicit. We want it to be a tester protocol, and which means that when the compiler looks at this code, right, when the compiler looks at this code that we're going to run, we want to know that tester variable here is, when we do it like this, is this. This is what our aim is. We want the compiler to know tester1 is definitely a tester of generic type integer. And but we want a function that can do everything and anything and return a protocol with associated type. And this is what our aim is. But right now, inside of our get tester, we are not being generic. We're being specific to this one tester. But we want to have a concrete type that conforms to tester protocol, not the concrete type returned. So we're going to have some way, we need to have some way of telling the tester protocol how to create yourself, first of all right? And we can do this by just doing an integer here, and then we're going to say item is then t, all right? Well, now our struct, it already conforms to this because it's already got automatically a initializer here already. So we're happy with that. So now we just need to say, hey, we want something returned that is of type tester protocol. So let's just move the type to get tester, and let's just say that. Let's say, hey, this T must conform to tester protocol. And when we run this now, you're like, well, wait a minute, tester does conform to tester protocol, but this is at the moment it's not generic because we've got this value here, right? And this value needs to come in this tester, and we're right now we are integer, and integer doesn't match type T, so we have to find, let's change this to so we don't have T's of T's of T's. Let's change it to this, all right? And let's change this to this. That, so we're all happy. Okay, so now we've got this tester protocol and we've got an integer. Well, we want to add this associated type to this one value. And how do we do that? Well, we just say t dot, and look, the compiler is even telling us you just use the associated type of item here, and we're like, happy days. So we've got the value in here, but this tester's like, this direct link into this tester here, so it's not generic, it's specific to this implementation, but we don't want to worry about the implementation. So how can we instantiate this tester protocol? Oh, wait a minute, we know how to instantiate it because we've got an initializer. So we can just come around and say T here, and boom, the compiler errors have gone now. And now, look, we're using the same protocol here. Let's remove the generics from here, and what do we get? Generic parameter T could not be inferred. So now we've moved the problem all the way down to line 33 because we can see here that tester is of error type. It can work out what t.item is. That's no problem. It says, hey, I'm an integer, yeah? But I cannot work out what the concrete type is. So let's change this now, and let's say rather than this being a tester item, let's say that this is an integer, which we can then say this is an integer. We can say this is an integer. And let's say this is of type string. And we just put the string here as per normal, right? And now we know that we've got tester integer and tester string. And our function here doesn't know about tester string or tester integer. So let's now create two of these, and we'll say tester int and tester string. And let's actually put a string in here. And we still have a problem because we can't infer T. So we have a couple of ways of doing this. We can either say tester int here, and we run this, and cannot explicitly specialize a generic function. Okay. Well, we can come here and do it this way. Tester int, all right? Here, now you can see first warning gone, all right? And now we can come to the second one, and we can say tester string, warning gone, boom. So what we've done is we've told this generic function that, hey, the return type, the concrete type, is going to conform to tester protocol. We're saying that the parameter of this one function is going to be the associated type of this one protocol here, which is item, and we are going to instantiate this type using the initializer that we've already said it has here, and then we're going to return that. And this is exactly what's happened. So now this this tester int is nothing more, which is more than likely what will happen in the compiler when it's optimizing the code. The likelihood is it will more than likely convert it to this, right? Because it goes, well, wait a minute, I know what this function is. I know what type it's going to give me, so I can replace this one code with this. I mean, that's going to happen a long, long way down, but it doesn't need this function anymore. However, you have a function to generate these different types, and you can keep creating them and creating them. So we know that our tester int variable is going to have the type tester int at compile time, not at runtime. It's going to be at compile time. This is the really interesting thing about generics, is to understand is how we can write generic code. And we just need to keep thinking, okay, what does the compiler know? What does the compiler not know? And how is the compiler trying to help us? Okay, so now if we remove this init from here, do we still get there? No, because look, type T has no member in it. It doesn't know how to do it. So let's change this to a class, and this class tester int has no initializers, as we know, but structs can be initialized. So this one tester int is perfectly fine, and as we can see, but it doesn't conform to this. So we have to say, and we said item is then item here. So this is how you can solve this. But as you can see here, we need to say required in the class, because we've forced it. This is the we've forced it to be a required initializer. Anyway, I just wanted to show you how we can get around this. Is when you want to return a specific concrete type that has associated types, you need to remove it, and you need to remove it here to the parameters, and then you can start accessing the associated types using the dot notation here. And when you want to instantiate them, that's where you need to put the initializers within inside of the protocol as well. And you can instantiate structs, or you can instantiate classes as well. So there we go. This is another insight to you to now generics. And what's really interesting about this is that whilst we were doing this, we've kind of introduced you to opaque types. Now, opaque types are allowing you to turn around basically and saying tester protocol here, but this is another video. All right, so but opaque types, sorry, are basically saying it's going to be some tester protocol, and this is doing the same as what we've just done here. We're forced the compiler to work it out at compile time. All right, and that's basically what we've been doing. Is we've been saying tester int. We've only got get item. So if we add another function here and say get other item, and we say return int, and we do this, you can see here we don't get other item on this tester int, because it's only conforming to tester protocol. So we've managed to hide this implementation of this class. All right, and that's where the likes of opaque types start becoming handy. But in order for you to really understand opaque types, it's super important for you to understand the generics in the background that's happening before you look at opaque and box protocol types. With that said, I really hope you've learned something from this one video. If this has been hard for you, don't worry about it. It is difficult, and it's also just as difficult to explain it. All right, and I didn't make this video just once. I made it a few times. All right, because not because I messed up. It's just because I hit a wall when I went, oh, wait a minute, I've done that wrong. And this is how it can be with generics. You've got to understand it inside out, and it's not something that stays in your brain permanently. So you as long as you can understand how to read the documentation, how to let the compiler help you, and so on, then you will get there. But you really need to understand the different rules for the protocols, and how to access the associated types, when you can access the associated types, and when and where you can use them. With that said, thank you very much for watching. Don't forget to like, subscribe, share, and do all of the other social media things that you can do to this one video. And if you do have any questions, feedback, concerns, as always, let's start a conversation in the comment section down below. Thank you very much for watching. My name's David Thorne, and I'll see you in the next video. Ciao, ciao, and goodbye.